Howdy folks, today we're going to be looking at Leetcode problem 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. So let's take a look at how we go about that. So here's our problem. Given a string S, return the longest palindromic substring in S, that being the longest substring that is also a palindrome. So for example, if I add ABBAC, the longest substring that's a palindrome is ABBA. Right? So this adds kind of an extra little filter that we have to do, but also is kind of a common class of problems, right? Return the longest or the something substring in S. So this is a very common problem set that's used because it's easy to figure out what's going wrong and it's not too difficult to do once you understand the tricks around it. So let's take a look at our data translation path. So we start off with a string, okay? We want to get to the longest string, substring here. How we do that, first we get a list of substrings. We get a list of substrings that are palindromes. Note A, B, and BB, those are palindromes. They're completely valid palindromes, even though they're one letter. There may be some debate over whether or not a single letter can be a palindrome. I would personally say it is. You should ask your interviewer. So if you come up with something they say, yeah, palindrome, then ask them, is a single character a palindrome in your estimation? Then the better question, is an empty string a palindrome? Because by some definitions of a palindrome, an empty string may be a palindrome because all of its characters, the left and the right, are equal because it has no characters. So it's important to nail that down. That's the kind of question that you really want to get figured out before you go down this path. So then once we have our list of substrings that are palindromes, we can just find the largest one, right? So let's see what our brute force solution looks like. This is going to be O of n cubed. This is a very bad solution. Should not be your final solution, but why do we start with this solution? We start with the solution because it's easy. This is an easy solution to get, and I guarantee you an interviewer is going to be more, they're maybe not impressed is the good word, but they're going to be happier if you give them a very poorly, a very poor time complexity solution that works, as opposed to trying to spend your entire interview coming up with an O of n solution and failing and never actually delivering anything that works. They are going to want this. Then they want you to iterate on it. So definitely do your brute force solution. Do your worst case solution first and then iterate on it, because that also shows your interviewer how you think. And so it can provide very important stuff in your thought process. And so that's why we start with this rather than going immediately to the more complex versions. So we generate all the substrings. We loop through the substrings and filter out the ones that are not palindromes. And then we loop over all the palindromes and find the longest one. So let's take a look at how we would do that. To start off with, we need to generate our substrings. Let me see if I can make this a little bit bigger. That's a little bit better. Okay, so substrings equals an array. And then I'm just going to do a standard for loop. Less than s.length, not O, plus plus. And then for let j equals 0, js.length, j plus plus. Technically, this should be j equals I. Then substring, substring equals s.substring, I, j. Remember, in this case, j is non-inclusive, meaning that you'll get I up to j, non-inclusive. We may have to tweak some stuff to make that work appropriately, such as doing j less than or equals. That's an important thing to pay attention, right? So that's why we want to start with a very simple solution. If you're whiteboarding this, try to, at this point, run through a very simple example yourself just to make sure that you're doing everything that should, because an interviewer will notice if this is off. Push substring, substring. All right, so now what I'm going to do, just going to console log my substrings. Test. It's not a bad thing to test this. If you're doing this in an interview and they're having you write code in CodePen or something like that, do a console log, run it. See what happens. Your interviewer is not going to hate that. even though I know I'm getting the wrong answer, I just want to see, okay, you can see a bunch of empties there. I get B. So for BA, BAD, I get B, BA, BAB, BA, BA, and the node D, which means that I'm cutting off the last character. Put an equals here. Run it again, see if it works. Especially if you have CoderPad for this, you can always just keep running it and see if it happens. There's my BAD. I don't like these empties. These empties are happening because J is equal to I. And if I pass I, so let's say it's 0, I pass 0 and 0 into here, it's not going to give me the first character because J is J is exclusive, not inclusive. I is inclusive, meaning it will be included. J will be excluded, which means it just gives me 0. If I set this to I plus 1, there we go. B, BA, BAB, BAB, etc. It goes all the way down to D. So now this is what I would expect to see, right? I expect this. This is good. You can see I had to tweak this with a little bit. Not a big deal if you have to do that, but explain your thought process. Say, okay, you know, I'm cutting off that end. I think that's because of the J. I think I just need to put an equals here. Let's see. Okay, that works. Oh, and now it looks like I'm getting these empties. That's not going to be a big deal, but I don't really want to deal with that. So I'm going to put my +1 here to advance that pointer. Kind of understand like why we do that. Basically, the reason why we do that, the equals, is because if I don't have that equals, the inner loop ends before it gets to that last character, or rather it ends right as it gets to that last character. And remember, the J is exclusive. It gets excluded. So the last character then gets excluded from the substring. So if I do this, it actually, J goes up to 1 past the length of the string, technically. Or not really, but like it goes up to the length of the string, which means that if I substring, it's going to include that last character. The +1 is to make it so that if J equals I, it's going to be an empty string because of the way that substring works in JavaScript. If I do that +1, there's always going to be at least one character in the substring, which I want. Oops, I don't want to submit that. Oh no, now they're judging me. They're judging me very harshly. Okay, and they're like, yeah, that's the wrong answer. Yeah, I know it's the wrong answer. It passed 0 test cases. All right, so let's see. We've now got these. Next thing we want to do is filter them, okay? Filtered substrings equals substrings.filter string. Now, what we're going to do in here is one of the easiest ways to handle this stuff is just to just loop over the whole thing. Though technically, to figure out a substring, you only have to loop over half of it. And so what I'll show you is kind of like a double pointer method. So what we're going to do here, we're going to loop over, first of all, string.length I++ char equals string of I. Okay, so that'll go through all of those, right? Then what we're going to do is we're going to say end pointer equals string.length -1. Why do we do the -1? Well, because remember, strings are 0 indexed. So if I have a string of 3 characters, a string of 3 actually is off the end of the string because it's a string of 0, 1, and 2. So I want this to start at the length -1 because that's actually going to be the largest character. So const end char equals string end pointer. Okay, so now I've got the character and I've got the end pointer. Now at the end of this, I'm actually going to subtract my end pointer. So my I is going forward. My end pointer is going backwards, and they're going to meet in the middle. And actually with this, because I'm not ending at half the string, they're actually going to cross in the middle and continue over. The important bit is, though, at any point, these two characters should be the same. So let me show you why. If I have A, B, B, A, for instance, my first character starts out, or my I starts at 0, which is A, and my end pointer starts off at 3, which is A. Oops. Okay, those match. Then I advances to 1, which is B. This one goes back to 2, and that is B. Okay. Then they switch, because of just the way it's set up. Actually, no, we can do it without the switching. But basically, that's how it works. You start a pointer at one end, you start a pointer at the other end, you advance them at the same time and check each character, and they should be fine. and they should always be equal. So I'm going to say if char does not equal end char, then right then we know we're not going to pass our filter. This is not a palindrome. So we're just going to return false. At the end here, we're going to turn true. And then let's console log our filtered, I call it filtered substrings. So let's try that. I actually want to make this a little bit. I just kind of want to make this a little smaller, but I also want you to be able to read it. So we'll see. We'll see how it goes. Okay, B, BAB, A, ABA, BA, and D. So this is actually pretty cool because these are palindromes, right? Now the important thing to remember about palindrome though is if it is an odd number of characters, we actually don't care about the character in the middle. Because the character in the middle doesn't need to match with anything. We only care about the characters other than the middle. If it's even, we care about all the characters. But in this case, we don't care about the one in the middle. Which means I can actually make this a little more efficient by having I less than string.length divided by 2. I only have to loop over half the string. And in the case of this being an odd number of characters, then I only need to loop over half the string minus 1. Or the floor, that integer value. Because, like let's say here, 3 divided by 2 is 1.5. I only need to loop over the first character. So if I run this, I should get a similar result. Did I just try to submit that again? I think I just tried to submit it again. Okay, and then case 2, C, B, B, D. C, B, 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 and D. Makes sense to me. That's the biggest palindrome is BB over here. So now the only thing we have to do, now that we have our substrings, we have to figure out which is the largest one. Now there's a couple ways we could do that. The way I would honestly do it is I would just keep track of the highest as like a variable and then loop over it. But what you can also do is you can sort. So sort. And I think this might work. Let's try it. Let me just see what this does. So, because I think sort without this will do it. Oh, filtered string. No, substrings. That's why. I think a sort, I could be wrong. I think a sort without this will do it alphanumerically. And so I think that might work. No, it doesn't. It does do it alphanumerically, but not by length. All right. Well, in that case, we're going to return a.length minus b.length. And I think that might be backwards, but let's run it and find out. That is backwards. Okay. So B, A. Remember, for sort, it expects a 0, a positive, or a negative number. A negative number tells it that B should be before A. A positive number tells it that A should be before B. And a 0 tells it that they don't need to switch places. So oftentimes, I don't remember that all the time. So what I do is I just do 1, and if that doesn't give me what I want, I just switch the order. But you can always do something like this. And then you can see BAB, ABA, etc. So now I know these are in order, so I just return filtered substrings 0. So I just return the first one in the list. We run that. And that accepts them. So this is very inefficient. But it is... this is O of n3. So how do we know that? This particular thing here is O of n2 because we're looping over the string and then we're looping over it inside that. That means that substrings is an array of n squared size. So if we loop over it again, say the filter here, this by default is an O of n squared operation because substrings, there's n squared of them. Then inside here, we're also looping over half the string. O of n over 2. The important thing is, though, O of n over 2 is basically O of n over 2 is equal to O of, this is math, n times 1/2, and constants disappear. So this becomes O of n. And because it's inside a loop that's running O of n squared, this becomes O of n cubed. Very inefficient. Let's submit it and let's see what they say. All right, so it actually did accept. They were like, yeah, this is great. This is fine. This is accepted. You can see the runtime is terrible. It's at the very far end. The memory usage is terrible, very far at the end there. Not a great solution, but it does work. That's the important part. If you've got a solution that works, you're halfway through the problem. Because, and the reason is, in the real world, and interviewers will generally know this, once you get a solution working, you've proved that it can work. From then, you can take time to figure out clever ways to make it easier, to make it work better. Maybe the input is bad. Maybe you could filter the input before you put it into this function if you can't make it any better. This one we can make better. So let's take a look at what we got here. We've got our function here, our 2 for loops, right? And then this becomes pretty problematic in here. Now I'm gonna make a slight change here for something, okay? Also, this is also an O of this doesn't really matter too much because this is never going to be worse than O of n squared. It's this operation that really is killing us right now. So what I'm going to do is I'm actually going to take this whole thing. I'm going to put it in here. Why am I going to do that? Why am I going to do that? So the reason is because I want these loops all lined up. If I've got a loop down here, it's going to be a lot harder for me to eliminate that loop. But if it's in here, I can do some clever things. So let's take a look at this. Okay, so we've got our string. This actually should be substring because that's what we're dealing with here. If char is not equal in char, I should probably make this a let, honestly. Bad habits. Is valid equals true. And then in here, we're going to say is valid equals false. Remember, this is the flag. We're assuming this is true by default. And then if we find something that makes it invalid, we change it to false. How to use flags is a little complicated, but it generally depends on is the check that you're doing inside your loop going to verify that it's true or verify that it's false? Because whatever the opposite of that is should be how you start. Because then if that check never happens or doesn't ever succeed, then you have the opposite by default. So in this case, my check is going to verify that it's false, so I started off as true. So then I'm going to say if is valid substrings.push substring. And now this, I'm just going to change this to here and here because we're not actually filtering it. Let's run that. So basically what I did here, I didn't do anything different from what it was before. I've just rearranged the system. It's still just as inefficient. Now it might be even a little more clear why it's inefficient. I still get accepted on both. But now I've got my loop, my loop, my loop. The reason this is important is because now I can start taking some time to actually peel apart these loops. And when you peel apart loops, oftentimes it means that you're going to want to be doing something else inside these other loops that lets you get rid of this loop. So let's say, okay, we have our substring. So what we were doing before, right? What we did before is we had the ability to, or like the last time we had to do with a substring, we were kind of looking at character by character as we built it. And so I want to get rid of one of these loops. And I'm kind of hoping, and probably by get rid of, I mean like merge them, and so that I don't have to do them. I'm kind of hoping we can get rid of this one actually. Right? And the reason is, let's say we have this I and we have this J. Our substring is going to be between I and J. But we've already looked at all the characters before then. So as we move forward, let's say we have A, we have AB. We have two characters. Now I can look and see that the character I just added is a valid, does it have a valid character on the other end. So really, if I check the characters at I and J minus 1, for reasons we'll get into, if I check those characters and they are the same, then I know that those two are the same. Now the problem begins, what about the inner characters? Are those the same? So how are we going to handle that? So the main thing that we need to prove, let's say we have a palindrome, right? Let's say we have ABBA, or better, ABCBA. If I am working with A, at this point, I can easily in constant time check that it matches the first character of the string. That's easy to do. I have access to that, so I can verify that. The problem is I need to have proof that this BCB is also a palindrome. Because if I know that, then I know the whole thing's a palindrome, right? Same with this AB. If I see A, okay, that matches. If that BB matches, then I know that's a palindrome. And the issue is we're building our strings this way, right? We're building them A, AB, ABC, ABCB. And so at this point at ABCB, I'm checking B against A. And let's say I'd already checked BC. I know that's not a palindrome. I know this isn't a palindrome. But then how do I check to see if this is a palindrome? That is kind of the complicated bit. And so what this almost indicates is we need potentially a better way, or maybe a different way of generating our substrings. Because if we want to generate them, this is just a train of thought I'm following. The reason I'm explaining this to you is because when you're in an interview, you need to explain your dead ends too, because the interviewer needs to see how you're thinking. So basically, if we could figure out some way to generate these strings from the middle outwards, that could be kind of interesting. Because from the middle outwards, we know we start from that core, and from that core, maybe we start from 1 or 2, and we say, okay, you know, this is a palindrome, then we add characters onto each side. So that could be kind of interesting to do. We could step through this, like we start with B, right? And then maybe we start adding characters onto the side. We say A, okay, B, AD, etc. Then we get to A, and instead of saying B is no longer something we care about because we've already dealt with all those, we start adding characters onto both sides. Okay, and then we get BAB, which we know would be a palindrome. We get BABA, we know it's not because A doesn't match B, etc. We move on to B here. We add A and A onto both sides. Then we add B and D. So you kind of see like building the substring from the middle outwards. And the reason that that would be helpful is because if we can build the substring from the middle outwards, not only does that let us very early on discard pathways, right? So as soon as we get to BA, if we're starting with B and we get A, and we don't have another character on this side, we can immediately discard that pathway. BAB we would have gotten, but remember, we're not checking against this whole string. We're checking against adding onto the side, and we know BAB will be handled as soon as we get to the A. Also, if we're on the A, let's see, we get B, cool, that's a substring. We add that to our list. We hit A, and we know there's nothing on the other side. Well, we know there's no way that could possibly be a palindrome. So we toss it away. Or, you know, maybe we check it against this here. Doesn't match. Though I think that we could probably, yeah, we probably just toss that away. For like ABBA here, we start off with maybe B, and then we say, okay. Like, and this is where it gets tricky, because this works really well for the ones that are odd numbers of characters, right? But for even numbers of characters, we'd have to do something a little different. Because for the odd number of characters, we start with a single character, we add 2 characters onto each end, and as we keep going until we get to a point where there's a mismatch, at which point we just give up on the whole thing because we know it could never be a palindrome again with the way we're building it. And if there is a longer palindrome, it'll get picked up somewhere else along the way. That is still O of n squared because we're still looping twice over every character, but we're doing it in a slightly different way, which kind of makes it a little interesting, I think. But these middle ones, this is where it becomes kind of problematic. The ABBA here, we would probably have to say, okay, we get to this B, we add on to both ends. This one matches here, so maybe if it matches the existing one, we just go one more step and grab another character. That could work, because then we'll have that core, which... So that basically the idea that I'm getting at here is if we can some way guarantee and make the assumption that a certain chunk of our string is already a palindrome, then adding new characters on, we just have to check those 2 characters, which can be done in constant time because we know where they are and we don't have to check the whole string. That would allow us to eliminate one of these loops, because then we'd be doing the checking as we're going. Um, this is getting a little long, but that's kind of an idea. And again, like the thing that's cool about interviews, or if you have a cool interviewer, is if I explain that to an interviewer, and we're running up on 3 minutes left to go, they're usually cool with that. The idea is you don't need to write the code, you need to convince them that you could, if given enough time. It's understood that 45 minutes, half an hour is not enough time for a lot of these problems, especially at a junior level. Your job is to convince the interviewer that you understand well enough what the problem is in your solution that you could write the solution if you had half an hour more. Because if you give them that, they will go away with that and they will write a report saying, yeah, this person, they ran out of time, but I'm confident that they could have gotten the solution we wanted if given enough time, because in the real world, you are going to have that time to do that solution. So yeah, going through that, I'm not going to code this out right now because it probably honestly would take me another 7-8 minutes, and I don't want this video to run that long. But that is kind of how I would get rid of that. So what we did, we went through the O of n cubed solution, went through that works, and then we looked a little bit at what an O of n squared solution was and kind of noodled on that. Next time I'll try to code that out so you can see what it actually looks like. Anyway, that's all for now. Thanks for watching, and I'll see you next time.